When it comes to the center of the Milky Way galaxy, for many decades the consensus has been that, well, there seems to be a supermassive black hole here. And we even took a picture of it a while back. This is known as Sagittarius A star. Although technically here we're just seeing the shadow of the black hole by observing radio emissions coming from the outskirts. But this recent study that we're going to be discussing today proposes something slightly different. What if this is not really a black hole, but instead a really massive chunk of mysterious dark matter? And the thing is, in this study, the actual explanation is kind of intriguing. And so, hello wonderful person, this is Anton. Today we're going to discuss the study you can find in the description that in essence tries to explain certain mysteries about the Milky Way galaxy by making this somewhat intriguing proposition. And a proposition that, at least in theory, does not violate any physics and also kind of makes sense. And so let's discuss the problems that it's trying to solve, and of course discuss the implications if one day this is proven to be correct. But to understand exactly what we're discussing and why this might be a big deal, let's discuss what we've already known based on decades of observations. And so let's discuss some of the more important previous observations and previous studies. And so let's talk about this object approximately 26,000 light years away from us. And so first we know that whatever this is, it seems to be pretty massive, 4.3 million solar masses in total. And we know this because a lot of observations of stars nearby confirmed its existence. Many of these stars move in a somewhat bizarre way around this central point, and whatever this point is has to be massive enough to make some of these stars move at thousands of kilometers per second. And because of this detection back in 2020, researchers even won the Nobel Prize that we discussed in one of the videos in the description. And so in essence we know that something is here because of this group of stars usually referred to as S-stars, whipping around an invisible object at incredible speeds. But it's really the precise orbital parameters of each of these stars that over the years allowed scientists to triangulate the exact position and of course discover the exact mass. And so based on many different papers, the conclusion was that supermassive black hole seems to make the most sense. Except that there has always been this one problem. For some reason, this is actually a lot smaller than a lot of other supermassive black holes, and more importantly, it seems to be super quiet. Now, occasional flare-ups have been detected, with certain X-ray emissions detected in the last few years, but there's always been this problem of this black hole just not being active enough, and more importantly, when scientists expected some kind of a flare-up or some kind of a major disruption, such as the event in 2011 where researchers expected a major tidal disruption event, where a star that was passing close to the black hole should have been shredded apart, releasing huge amounts of energy, unfortunately nothing seems to have happened, and the star basically survived and seems to be still orbiting this region. And so because it's so quiet, and because it has such a small mass and low luminosity, it was always a bit of an outlier and basically made no sense. And that's because a lot of similar galaxies in a neighborhood always possess much larger black holes and are very often classified as Seyfert galaxies, or basically a type of a galaxy with an extremely bright core. But on top of this, there's always been this other unusual mystery coming from the observations from the Gaia telescope. This is of course the extremely powerful telescope that was able to track the motion of stars, allowing us to create very accurate three-dimensional maps. And here, along with several other studies, in the last few years scientists discovered what's known as a Keplerian decline, or essentially a kind of a decrease in orbital velocities at much greater distances from the galactic center. And for the Milky Way galaxy, it seems to start happening approximately 52,000 light years away from the center. And basically at this point there is a sharp decrease in velocity, with stars moving approximately 30 km per second slower than all of the other stars in the galaxy. But in most galaxies we expect the velocity to be relatively flat and not change much because of the effects from the mysterious dark matter. And this was actually a somewhat recent discovery from 2023 and created a bit of a mystery. Here's roughly how this new curve basically looks like. And while this bizarre decline indicates that there seems to be some kind of a more complicated model when it comes to the mass in the galaxy, or that for some reason the mass is reduced on the outskirts. And right now not a lot of physical models can explain this, and not even the models involving various propositions like the MOND, the Modified Newtonian Dynamics, with the initial study concluding that either the Milky Way is just a lot less massive, or the dark matter halo is very small. Although I guess the main point was that it essentially created a new mystery. And that's essentially one of the main reasons for this new proposition and this new model. And so basically here, the dynamics of these S-stars in the center of the galaxy, the lack of activity from the central black hole, and of course this Keplerian decline, in theory could be explained if maybe there was no black hole. Or just to rephrase this, the researchers now propose that maybe it's not a black hole, but instead a superdense core of fermions, which are light subatomic particles that we think may make up dark matter. And in this model, the dark matter doesn't just float around the galaxy, instead it might form these unique cosmic structures representing very compact and very heavy objects that are usually surrounded by a much larger, thinner halo, and of course a lot of normal mass and normal gas. But in this case, this core would be so dense and so massive that its gravity would still feel very similar to a typical black hole to any stars orbiting nearby. And because there would be a lot of gas interaction and a lot of relatively dense regions, once in a while it could also produce certain emissions, such as those X-ray emissions detected a few years back. But because this would not be a black hole with an event horizon, it would not cause tidal disruption events, and it would not destroy stars. And so even though it sort of acts like a black hole and possibly even looks like a black hole from a distance, here the scale would be very different. And so for example in the previous black hole models, here the explanation was only about the center of the galaxy. But in this new fermionic model, it sort of acts as a unified entity. Or basically it explains two different things at the same time. It explains the motion of these stars, it explains the lack of activity, but more importantly, it explains the very slow, large-scale rotation of stars and gas on the outskirts of the galaxy. And so in essence it kind of combines several mysteries and tries to solve them by changing what we think about dark matter. But in order to see if this actually makes sense, researchers also used what's known as Markov chain Monte Carlo statistical sampling in order to compare how three different models fit the actual observations. And so in the first model, we had the standard black hole. In the second model, they assumed that this was some kind of a chunk of dark matter, but it was not very compact. With the third model assuming slightly higher energy particles, but the object was a lot more compact, closer to the point where it would collapse into a black hole. And they then essentially tested this with various orbits of stars orbiting this region, with one of the most famous being the S2 star, whose orbit has been established very well. But also several bizarre G-objects we discussed previously that even today don't have a very good explanation. These are basically these very strange dust-enshrouded objects that kind of look like gas clouds but seem to behave like stars. And these were only discovered a few years back, and so we still don't really know what they are. But when it comes to the results, both the fermionic dark matter model and the black hole model seem to produce extremely similar results and can actually explain pretty much all of the observations, including the emissions and the relativistic effects. But turns out that the second model, involving smaller particles and a somewhat fuzzier, less compact chunk of dark matter, seemed to fit just a little bit better, with the overall conclusion from the researchers suggesting that the fermionic dark matter model predicts a much tighter and a more compact structure than the standard models. But more importantly, it was also able to explain the behavior of stars on the outskirts of the galaxy, matching the bizarre slowdowns observed by Gaia. Okay, that's cool, but can it actually explain this? Can it explain the shadow of the black hole observed in 2022? Well, the study in this case addresses this as well. And that's because they also discovered that this dense dark matter core would also bend the light very strongly, basically mimicking the shadow of a black hole observed with the event horizon. So essentially it would still look kind of like a black hole, resembling a dark circle surrounded by a bright ring of light. Or just to rephrase this, when it comes to physical observations, nothing we've seen so far seems to break this model. Okay, so this might sound very complicated, which means that we should probably summarize the main points and decide which one seems to be better. The previous view was that Sagittarius A star was a black hole, and the galaxy was surrounded by a dark matter halo that was separate and unrelated. And exactly what it's made out of is of course unknown. But as I mentioned, this model did not answer all of the questions. There were still certain mysteries. But the new view suggests that the central object and the outer halo are actually two manifestations of the same substance. And in this case, there is very likely no black hole here, or basically no singularity, just a very dense ball of particles, massive enough to form something that resembles a black hole from a distance, but something that does not produce the same effects, or something that represents a massive concentration of the most mysterious substance in the universe. But is there any way to prove this? Well, it turns out that there is one way. Right now, all of the data we have of these inner stars is not really precise enough to tell if this is a black hole or a chunk of dark matter, but the researchers think that if we can observe what's known as a photon ring, it could give us the exact answer. Okay, Anton, what's a photon ring? Well, a while back NASA made this really cool visualization based on simulations of various black holes in order to help us understand what's possibly happening around them. And the previous images that we've seen before only show us the accretion disk and the central shadow, scientists believe there should also be what's known as a photon ring. Basically a kind of a region where a lot of photons get trapped for a very long time, but eventually escape, making one part of the black hole really stand out. This really cool visualization by Hugo Spinelli explains this just a little bit better. And so technically all black holes should have this, but if this is a dark matter core, it should not have this, because chunks of dark matter should not be producing this at all. And that means that in the future, once we observe central black hole in the Milky Way with some additional instruments, we might be able to tell one from the other. And so, for example, future observations from the gravity interferometer in Chile may be able to find certain signatures of this, potentially confirming one of these propositions. But what makes this study exciting is, of course, the fact that it doesn't really invent new physics and does not propose anything too extraordinary, but instead focuses on certain unexplained phenomena from the last few decades and tries to explain them with something scientists have been actually looking for a very long time: these bizarre dark matter particles. And so for all we know, maybe there's just a chunk of them right in the center. But one implication from the study is that it might also suggest that the Milky Way galaxy is a bit of an outlier, specifically because this Keplerian decline does not seem to apply to all galaxies. And so that could be because of the dark matter distribution inside the Milky Way that seems to be a lot more compact and seems to form tighter structures. In a lot of other galaxies, it seems to be a lot more fluffy and seems to be distributed a little bit differently. But if this study is correct, these fermionic dark matter cores would also exist in other locations as well, with many of these dark matter clumps potentially serving as the original seeds that might actually collapse to form supermassive black holes once they accumulate enough mass from the regions nearby. But maybe for the Milky Way galaxy, this very strange dark heart just never really became a massive black hole and remained a chunk of dark matter. And I guess more intriguingly, when it comes to various models of dark matter and the formation of galaxies, researchers actually do believe that a lot of this started as a concentration of dark matter before all of the gas started to accumulate around it and started to form stars and produce actual galaxies. And so technically dark matter does actually serve as a blueprint for most galaxies we've seen so far. But once again, for some reason, Milky Way galaxy possibly just turned out a little bit different. And exactly why, we still don't know. But at the moment, I think most scientists still think that this is probably a black hole. In other words, even though this is an exciting proposition, it will still take a lot more to confirm that this is not a black hole. And so until future observations, we're not going to know much more. But these ideas are still worth considering and still worth exploring, because for all we know, maybe they're right. And so until future studies, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM it directly, or by joining channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.